Hello, we are discussing about GATE 2012 ECE paper. Look at the question, which is a common data question, and it has given that one a linear non-reciprocal two-port network is shown, which has two ports, port A and port B, and 10 volts is connected at port A. So this is what 10 volts is connected at port A. And by that time, if 1 ohm is connected at port B, that draws a current of 3 amperes. If 2.5 ohms is connected at port B, that draws a current of 2 amperes. Then find the current drawn by 7 ohm connected at port B. Okay, so this is the first case given. If 1 ohm is connected, current drawn by this circuit is 3 amperes. 3 amperes, and the same thing for the same circuit. Again 10 volts is going to be connected. For this 10 volts connected at port A, and if port B is connected with 2.5 ohms, then current drawn by this is 2 amperes. Now we are going to find if this resistance is replaced with 7 ohms, what will be the current drawn by this resistance, that we are going to calculate. Okay, so look at this one. This is a circuit and port A is connected with 10 volts. So can you compare this one? This is going to be a two-port network, and the two-port network along with the applied 10 volts. Two-port network along with the applied 10 volts. Can I say that one, these two circles, red circles, okay, these two are going to be of same? Okay, because both are connected with 10 volts and both are related to the same two-port network, so that both are going to be same complex networks. Just only at the output side, port B, are going to be given with different resistances. So this complex networks now can be replaced with, okay, a complex network can be replaced with a Thevenin's equivalent. So the Thevenin's equivalent is same for both because both are going to be same circuits. Let us assume the Thevenin's equivalent is going to be consisting of one open circuit voltage VTH across the terminals, and now the Thevenin's equivalent is going to be replacing across these two terminals by looking into this circuit like this. By looking into this circuit, you are going to replace it. Complex network can be replaced with a Thevenin's with VTH in series with RTH. Thevenin's resistance in series with open circuit voltage at the terminals of interest. That is Thevenin's voltage. Now this will be port B that is connecting with respect to this diagram. Okay, when 1 ohm is connected, current coming from this one is 3 amperes. Okay, and with respect to second circuit, again we are going with the RTH and VTH because it is same. We are dealing with the same circuit. So RTH value is same, VTH value is same, but now this open circuit is connecting with 2.5 ohms. Then the current drawn by this is 2 amperes. Okay, and we know now these two circuits, we can calculate VTH and RTH. Write the equation for this one. Okay, equation can be written as, first one, VTH is equal to, okay, from this one, VTH is equal to 3 into RTH using KVL, 3 into RTH plus 3 into 1 ohm, that is nothing but 3 volts. This is equation 1. And from this circuit, second circuit, okay, from the second one, we can say VTH is equal to, apply KVL for this one. Now the current flowing is 2 amperes, 2 into RTH plus 2 into 2.5, which is nothing but 5 volts. This is second equation. Now simplify 1 and 2 equations and get the values of RTH and VTH. RTH can be calculated by simply doing 1 minus 2. Subtract equation 2 from equation 1. Okay, so this will be minus. So VTH will be 0 and 3 RTH minus 2 RTH is simple RTH and 3 minus 5. 3 minus this is RTH minus 2 is equal to 0. RTH minus 2 is equal to 0. 5 minus 5 plus 3 is minus 2. RTH minus 2 is equal to 0. From this one we can write it as RTH is equal to 2 ohms. Once you know RTH, you can calculate VTH either going through equation 1 or going through equation 2. So VTH is calculated by going through equation 1. 3 into 2 is 6 plus 3, 9. So VTH is 9 volts and RTH is 2 volts. Now we know the circuit equivalent, which is nothing but consisting of 2 ohms and with 9 volts battery. VTH. Now you can put any resistor across port B. Now this is port B. Okay, you can calculate the current drawn by that port B. Now we are going for the actual question. With 10 volts DC connected, that is nothing but same circuit. The current drawn by 7 ohms. Now port B is connecting with 7 ohms. Now port B is connecting with 7 ohms. What is the current drawn by this one? I value are going to calculate. So this is simply 9 divided by 2 plus 7, which is nothing but 9 by 9, which is 1 ampere. So the right answer for this question is C. 1 ampere is the current. So now we are going for the second question, that is for the same network with 6 volts DC connected at port A, 1 ohm connected at port B draws 7 by 3 amperes. If 8 volts DC is connected at port A, what will be the open circuit voltage at port B? Okay. So it was given that one. If 6 volts is connected, 6 volts is connected at port A and port B is connecting with 1 ohm. Okay, then current drawn by this one is 7 by 3 amperes. 7 by 3 amperes. And next case what it is asked is, so second case is given like this. Now 8 volts is going to be connected across port A, 8 volts, and find the open circuit voltage across port B. That is voltage across port B, VB, is going to be calculated. Open circuit voltage means if you are not connecting any resistor, what is the voltage across port B? Okay. So how to calculate this one? And it is common data question. You can get the information from the previous one also. Okay. So from that previous one, what we have seen is, so in the previous one we have taken it as if 10 volts is going to be connected, if 10 volts is connected across port A, okay, and if a resistance of 1 ohm is connected, by that time current drawn by this one is 3 amperes. Okay, this is what the information we know. If 10 volts DC is connected and 1 ohm is connected at port B, which draws 3 amperes of current, but we are interested in the open circuit voltage, that too at port B. And already we have seen that one, we have calculated Thevenin's equivalent for this circuit. So this circuit is replaced with a Thevenin's equivalent that will be having a value as VTH and RTH. VTH and RTH. This is RTH, which is 2 ohms we calculated, and VTH. VTH whenever 10 volts is connected, that was taken as 9 volts. This is port B. So open circuit voltage at port B is simply equal to voltage at port B is equal to voltage at Thevenin's equivalent across these two terminals. open circuit voltage at port B, which is same as Thevenin's voltage, because you are not connecting any resistor across port B. That means port B voltage is same as VTH. Because it is open circuit, no current is flowing through this RTH, so no voltage drop across RTH. Total voltage VTH will be available across port B. So VB is equal to directly proportional to VTH. VB is directly proportional to VTH. Can I say that one VTH is equal to 9 volts? Can I say that one? The answer VTH is equal to, that is V at port B. Open circuit voltage at port B is equal to 9 volts. Is this the answer? This is not the answer. Why? Okay. Why means whenever you are going with any circuit, if voltage changes for a complex circuit, if voltage changes, VTH changes. Okay, but not RTH. First we will prove this one, later we will go for the actual question. Okay, say this is a simple circuit I am going with. This is 2 ohms, for example. This is another, it's going to be 8 ohms. Okay, and these are the two terminals of interest, and it is connecting with something as 10 volts. Okay, now I am going to apply I am going to apply a Thevenin's equivalent across these two terminals. So what can be the VTH and RTH? VTH is equal to voltage across 8 ohms. Using a voltage division rule, you can write it as 8 by 8 plus 2 into 10. So 8 by 10, 10, 10 get cancelled, you will get it as 8 volts. And RTH for this circuit is equal to 10 volts is going to be shorted. Whenever 10 volts is shorted, 2 and 8 will be in the parallel. So 2 parallel 8. So that is 16 divided by 10, which is nothing but 1.6 ohms. Say VTH is now, that is now the changed voltage is 6 volts. Okay, now I am not going with 8 volts, I am going with 6 volts. Same circuit, but applied voltage is only changed. Applied voltage is only changed. By that time VTH is equal to, okay, using voltage division rule, open circuit voltage across 8 ohms resistor will be VTH. So VTH is equal to 8 divided by 8 plus 2 into 6. So 6 by 10, that is 0.6 into 8 is 4.8 volts. 4.8 volts is now VTH. Previously it was 8 volts. RTH is equal to, Thevenin's resistance can be calculated by short circuiting the voltage source and open circuiting the current sources if exist. Now 6 volts will be treated as short circuit. By that time 2 and 8 will be in parallel. So again it is 2 and 8 will be in parallel, that is 1.6 ohms. Even if VTH is going to be changes, even if the supply voltage changes, VTH changes but not RTH. So for A, now you can think that one, this is what the circuit given, 2-port network. Okay, this is 2-port network given, and what we are applying is supply voltage. This may be 10 volts or 6 volts or 8 volts. Okay, by that time the equivalent circuit will be consisting of different VTH with common RTH. RTH is common, but VTH X I am writing. X is nothing but the voltage what you are applying. VTH X, like this you can replace. The circuit, the equivalent circuit will have the same RTH value, but it will be having a different VTH which is directly relating to the X value. Okay, so now we cannot say the same VTH is going to be valid for 8 volts, because for 10 volts if it is 9 volts, for 8 volts it will be different one. That different one you should calculate, that will be the answer. Okay, so for this 10 volts we have already taken, when 10 volts is applied at port A, then VTH of 10 volts is equal to 9 volts, that we got already. Okay, and RTH which is going to be common, that is 2 ohms. Now we are going to calculate the actual answer. Okay, now look at this one. If you are replacing this at that time, this circuit can be replaced now as VTH6. This circuit can be replaced as VTH6 and it is RTH. This RTH is common because only supply voltage is changed but not the two-port network, so that it is 2 ohms, and whenever it is connecting with 1 ohm, then the current coming from this one is 7 by 3. Current coming from this one is 7 by 3 amperes. So now VTH6 can be calculated by simply applying a KVL. So current flowing through is 7 by 3. So 7 by 3 into 2 ohms plus 7 by 3 into 1 ohm. So total can be written as 2 plus 1. So 3 get cancels. VTH6 is equal to 7 volts. Okay. Whenever 6 volts is applied, open circuit voltage VTH, that is at port B. Open circuit voltage at port B is 7 volts. Whenever 10 volts is connected, open circuit voltage at port B is 9 volts. Whenever 6 volts is connected, open circuit voltage at port B is 7 volts. Now we are going to calculate open circuit voltage whenever port A is connected with 8 volts. And this two-port network is given as linear. Linear is nothing but output and input are linearly related. Output and input are linearly related. That is, VB is going to be function of, okay, VB is function of applied source voltage Vs. That Vs may be, once it is 10 volts, the other time it is 6 volts, next time it is 8 volts. That will be treated as Vs, function of Vs. Okay, so VB is equal to function of Vs, that is also treated as simply VTH. Now this is a straight line equation because it is linear related, so you can write it as VTH is equal to some slope times of Vs plus intercept. Okay, mx plus c equation. So we are going in this way. VTH is equal to m times of Vs plus c. So we know two things: VTH when 6 volts is applied, VTH when 10 volts is applied. So get the two equations and find the value of m and c from those two equations. Okay, so from this first case you can get it as VTH10 is equal to m times of how much you are applying. By that time Vs is equal to 10 plus c. So VTH10 is 9. 9 is equal to m times of 10 plus c, that is 10m plus c. This is first equation. Second equation you can write it from this one. Okay, VTH6 is equal to m times of 6 volts plus c. VTH6 is 7. 7 is equal to 6m plus c. This is second equation. So now we have two equations. One is nothing but 9 is equal to 10m plus c. The other is 7 is equal to 6m plus c. Okay. So simply equation 1, this is equation 2. Subtract 1 minus 2. So you will get it as 2 is equal to 10 minus 6 is nothing but 4m. C get cancels. M value is 0.5. After knowing m is equal to 0.5, you can calculate c value. Okay, m is equal to 0.5, 5, 9 minus 5 is 4. C value will be 4. M value is known, c value is known. So by using the general equation, that is by using this equation, you can calculate VTH for any applied voltage. So now we are going to find open circuit voltage, that is VTH, which is also the voltage across port B when 8 volts is connected. Okay, so now VTH8 is equal to m times of 8 volts plus c, and m is equal to 0.5 into 8 plus 4 volts. So 8 into 0.5 is 4 and C value is 4. 4 plus 4 is 8 volts. So this is the open circuit voltage at port B when 8 volts is connected is 8 volts itself. So the right answer for this question is C itself. C is the right answer for this question. Thank you.